Hi everyone, I am Dr.P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Today I am going to discuss about the thin film interference. In this thin film interference, the students can able to understand after the completion of the lecture, they can derive the cosine law in thin films, which is the most important to understand the remaining concepts of thin film interference. And they can also understand the conditions for dark and bright films. What is the condition for darkness, or what is the condition for a bright film, and this kind of non-reflecting films, etc. they can understand. So coming to a thin film interference, say you observe this figure. This is uniform thickness film whose thickness is given by T. T is the thickness of the film. It is a parallel film or uniform thickness film. It is a transparent film made up of either glass or a transparent plastic, even water or air film, no problem, whose refractive index is given by mu. Mu is the refractive index of the film, say. Here, when a monochromatic beam of light OA, it is incident on a thin film, generally it undergoes multiple reflections and refractions, means part of the light is reflected, part of the light is refracted into glass. Again at the bottom edge, here part of the light is reflected and part of the light gets refracted into air medium. Once again at the upper boundary, so part of the light gets reflected, that is dr dash, and part of the light gets refracted into glass. In that way, the light ray undergoes multiple reflections and refractions. Here, this is light ray 1, light ray 2, say, and several other light rays also will exist. But one thing, only the first two light rays contain considerable intensity. Moreover, they behave like coherent waves. That's why whenever these two light rays, this is one wave train, this is another wave train, say, the two waves superimpose on each other, they will produce an interference pattern containing dark and bright bands. So what is the condition for darkness? What is the condition for bright? Means what are the conditions for construct interference and destruct interference, that what we are going to derive now. For this, actually between these two rays, you observe, I just draw one normal, that is BD. It is one normal. From that normal, they have same path. Light ray 1 is covering an extra distance, this is AB. Whereas light ray 2, it is not originated at the point D, actually it is coming from all over the distance like this. So this light ray is covering extra AC plus CD. So what is the path difference between these two rays? That is given by AC plus CD minus AB. In general, we have to take the optical path difference, means the refractive index mu into geometrical path. So what is the refractive index? Mu into AC plus CD minus mu into AB. But mu is not there at AB. Why it is like that? Means AB is in the air medium. That's why it is 1 into AB. So what is the path difference here? Delta, you can write optical path difference delta, it is equal to mu into AC plus CD minus AB. But we don't know what is AC, what is CD, what is AB, something like that. We have to get them from the figure by using the principles of geometry. For that, coming to the first one, I take one triangle, AEC triangle. This triangle I am taking. So this is the AEC triangle. In fact, the incident ray making an angle, incident angle I. If this is I, on either side of the normal, that is also I. What is the total angle here? 90 degrees. So 90 minus I, this is 90 minus I. Moreover, this is 90 degrees at the point B. In a triangle, total angle is 180 degrees. So one angle is 90 minus I, other angle is 90. So at the point D, at this one, you will get I is the angle. Similarly, R is the angle of refraction. I just draw one normal, EC is the normal. So here it is making R on either side of that one, that is also R. So now I am taking the angle AEC triangle. From this triangle, this is R. Therefore, cos R is equal to EC by AC we get. But already EC is having the term T. T is the thickness of the film. T is the thickness of the film. That's why EC by AC means T by cos R. From that one, we can get AC is equal to T by cos R we get. But one thing, AC is also equivalent to CD. That's why AC plus CD 2T by cos R we get. Next, to get this AB, take the triangle ABC triangle. This is A, B, C. So this is I. I take sin I say. Sin I is equal to, so this cos 90 minus I, instead of that one, you take sin I, it is equal to AB by AD. Actually this AD is equivalent to AE plus ED. Automatically we get AB is equal to AE is equivalent to ED, 2AE sin I we get. So substituting all these things in the equation number 1, we get this delta is equal to, this delta, path difference delta is equal to 2 mu t by cos R minus 2 mu t, something we get here. Actually what we are doing is, to get this AE, I take the triangle AEC triangle, you take tan R. Tan R is equal to AE by EC, automatically you will get AE also. Substituting all of them, you will get delta is equal to 2 mu t by cos R minus, so here one thing I am doing, dividing and multiplying with sin I. Automatically sin I by sin R is nothing but mu, that is Snell's law. Therefore, path difference finally what we get here, delta is equal to 2 mu t cos R. This is the optical path difference between the two reflected rays we are getting. But one thing, there is one concept, whenever the light is reflected from the glass to air, what happens? There exists a phase change or path difference, lambda by 2 path difference, phi phase difference. If it is reflected here, means from denser to rarer to denser, such kind of path difference does not take place. That's why we have to take the optical path difference 2 mu t cos R plus or minus lambda by 2. You can take plus lambda by 2 or minus lambda by 2, anything you can take, but final result will not change. So this is the actual optical path difference we are calculating or we are getting. Now as per the first equation number 1, the optical path difference delta is equal to, so this is 2 mu t AC plus CD minus AB, completing means deriving all those terms, we get delta is equal to 2 mu t cos R minus lambda by 2. If this is equivalent to n lambda, construct interference takes place. If this is equivalent to 2n plus 1 lambda by 2, destructive interference takes place or darkness occurs. Now what is the condition for constructive interference? That is 2 mu t cos R minus lambda by 2 is equal to n lambda. Writing this lambda by 2 in the RHS, 2 mu t is equal, cos R is equal to 2n plus 1 lambda by 2. So this is the condition for brightness in case of thin films, whereas condition for minimum intensity, condition for darkness. So 2 mu t cos R is equal to 2n plus 1 lambda by 2, writing this lambda by 2 in the RHS, you will get 2 mu t cos R is equal to n plus 1 lambda. Finally, you can write n plus 1 lambda or n lambda, where n is equal to 0, 1, 2, 3, so on. 2 mu t cos r is equal to n lambda or n plus 1 lambda, both are same. That's why the condition for the maxima or brightness, that is 2 mu t cos r is equal to 2n plus 1 lambda by 2. Condition for minimum or darkness, 2 mu t cos r is equal to n plus 1 lambda. So in this one, what we have discussed is what is actually a parallel film or a thin film. So in that thin film interference, what is the cosine law? If you observe the cosine law, 2 mu t delta is equal to 2 mu t cos r plus or minus lambda by 2. This is actually called cosine law. The cosine law is delta is equal to 2 mu t cos r plus or minus lambda by 2, either plus lambda by 2 or minus lambda by 2. That path difference, that equation is called cosine law in thin films. Actually this cosine law we use in further derivations like Newton's rings experiment while deriving the radius of curvature of the plano-convex lens, or determining the wavelength of light, unknown source. So that kind of things we use this equation in the thin films. This is the most important equation which is known as cosine law in thin films. So in this chapter, in this topic, what we have discussed is what is the theory of interference in case of parallel film or uniform thickness film, and also we derived the cosine law. We extracted or we discussed the construct interference and destruct interference conditions. So that's it. Thank you.